Okay, we're going to finish up graphing this function. We're going to start with graphing y equals x cubed. And it's going to look a little something like this. And then we're going to graph its reflection, or its inverse. And we can do that using y equals x again. And it's going to look like this. And then from there, so that's y equals the cube root of x. Then from there we can do some translations by taking the 7, it's affecting the x coordinate, and that tells us we're going to go to the right 7 units. And then the 2 is affecting the whole function, and we're going to go up 2 units from there. So I would pick like the origin and take that point, and we're going to go to the left 7 and up 2. And so that will be the middle. And you can just give a little rough graph of what that would look like. So this is our function y equals 2 plus the square root of, or the cube root of x minus 7. Again, honestly, you could graph that using your graphing calculator. All right, let's take a look at what the definition of inverse functions is, and that's where we're actually taking the composite, we're putting the inverse into the original function and the original function into the inverse, and we're seeing if they're equal or not. If they are equal to each other, then we know that they are actually inverse functions. If they're not equal to each other, or they're not equal to x, then they cannot be inverses. So I take my function, I have f of x equals 4x minus 9, and I need to find out what the inverse of that is. I'm going to do our little trick here. Y equals 4x minus 9. We're going to swap the x and y so that I get x equals 4y minus 9, and then we want to solve for y. Swap and solve. I'm going to add 9 to both sides, so that gives me x plus 9 equals 4y, and then when I divide by 4, I get y equals x plus 9 over 4. And that's actually my inverse. So the inverse function is x plus 9 over 4. And then I'm going to do some do the composite functions. I'm going to take f of the inverse and see what that equals, and I'm going to take the inverse of f and see what that equals. Start with the original function, leave a little space there where x is, and I'm going to substitute the inverse in there. What will happen is our force will reduce, and 9 minus 9 is 0, so we're left with x. Kind of looks like it's already going to work out for us. Then I'm going to take the other function, I'm going to start with the inverse this time, leave a little place where the x is, plus 9 over 4, and put the original function in there. Again, this time the 9's will cancel, the 4's will reduce, and I get x. So you can see that both composite functions equal x. So we can say that f of x and its inverse are inverse functions. problem here. This is a physics problem that says the formula for the kinetic energy of a particle as a function of its mass and velocity is Ke, which is K, they use two letters, but it's one thing, kinetic energy equals 1/2 the mass times the velocity squared. So for part A, it says find the equation for the velocity of a particle based on its mass and kinetic energy. So we're going to take the kinetic energy equals 1/2 mv squared, and we're going to solve for v. So move everything over to the other side and get v all by itself. We'll start by multiplying by 2. So I get 2 Ke is equal to mv squared. Then I'm going to divide by m. So I get v squared equals 2 Ke over m. And finally take the square root. Then I get v equals the square root of 2 Ke over m. So that's velocity in terms of the kinetic energy and mass. Then for part B, it says we're going to use our equation from A to find the velocity in meters per second of a particle with mass 1 kilogram, so m equals 1 kilogram, and the kinetic energy, Ke, equals 15 joules. So the equation we came up with was V equals the square root of 2 Ke over m, and we're just going to substitute. So I take 2 times 15 over the mass, which is 1, and that's going to be the square root of 30. And then I'm going to simplify that, and I get velocity equals, or is approximately 5.48 meters per second. Part C just asks us why the velocity of the particles is not a function of its mass and kinetic energy. And just like we did with the composite functions, if we put the kinetic energy function into the velocity function and vice versa, what we find is that they don't equal the same thing, so they're not inverse functions.